Direct variation. It's usually a topic that's covered in Algebra 1, but I'll pretend that you've never seen it, okay? This actually shows up again in... It actually shows up again in calculus. We do this whole thing with like directly proportional, like something might be directly proportional to weight or time. And it's really simple. We say y varies directly as x. There's some non-zero constant k such that y equals kx. It's basically the equation of a line that goes through the origin where k, we think of k as like our slope, like y equals mx, all right? Now there's different ways that we can write this. We have this is gonna apply to different values of x and y. So like if we have two different points here, has the same relationship with 2 points, x2 and y2. No? I'll give you the example is different. This also implies y2 over y1 equals
x2 over x.
Or actually, I'm sorry, mix those around. Why did nobody say? Because if I were to divide both sides by x1 here, sorry, I wanted to write it as y1 over x1. And here, if I divide both sides by x2, then I'd have y2 over x2 is equal to k. Like if I divide both sides by x1 here, then k is equal to y1 over x1. And if I divide both sides by x2, y2 over x2 is equal to k. So if both of these are equivalent, right, they're both equal to k, then y2 over x2 is equal to y1 over x1. I wanted to write it that way. Yeah. Okay. Now, I actually like to write out the equation. There's two different ways. I actually don't care which way you do it on the homework. But the reason I like to write out the equation is because, again, you'll see it later in pre-calc and calculus where you have to write the equation relating them. So starting out with this, so basically as soon as you see y varies directly as x, I know I have this y equals kx. That's the relationship between x and y. We want, so here we have y is equal to negative 15 when x equals negative 5. Okay, so what I can do is I can plug in negative 15 equals k times 5. Divide both sides by 5, and we get k is negative 3. So the relationship between x and y is y equals negative 3x. Does that make sense? Okay. Literally, what we're going to do is we're going to find k first, right? Y equals k times x. So don't worry about the second part of the sentence. Just take this part. So they're saying when x equals 5, y equals negative 15. So what is our constant of variation?
What is the constant of variation?
I
know k is like, but
it's like slope.
Oh, okay.
Can you just do a proportion? I thought x equals negative 9.
Okay, now Jack said there were two ways to do it, hence this proportion here. Now, why did I say it was important to also be able to recognize the equation relating the two? Because you're going to use it later on. Sometimes I'm going to ask you just for the equation relating their direct variation.
I got it.
Okay? Now, we want to find out what y is when x equals 3. Well, we're just going to plug in, right? So I want to figure out what y is when x is positive 3. What do we get for y? Negative 9. Okay. So what did we do? First, we figured out the constant of variation, right? And then, right, that's the So if we plug that k back in, that gives us the equation relating the two. Then we plug in 3, and we get -9.
Oh.
Now, if you want, we can do it with the proportion,
That's my way.
right? So if I just do -15 over 5, that has to be equal to y over 3, right? y2 over x2 equals y1 over x1. So if we just do y over x equals y over x, and we have 3 values that are known, right? So I'd have cross multiply 5y equals -45. 2 different ways to solve it. Both are correct.
Someone's going to college.
Yeah, I know a lot of decisions are coming out right now. Okay, are we good with direct variation? Do we need another example, or are we good with that? Pretty straightforward? Okay. Okay. Just recognize if I ask you on the test, I say, what's the equation relating the two? You still need to be able to do this, because I probably will.
Like, if you want us to be able to like, make a formula like that.
Right, again, because you're going to be asked later, I like to also write out the equation. All right, joint variation. This is when we have basically one quantity varies as the product of 2 variables. So here we have the formula here. And then this is the formula that it would look like as a proportion. Do you see that? Yeah. K is the constant of variation. It just means how much do they vary. So if I go back to this last example, what's the relationship between x and y? Y is always a product of -3 times the value of x. So if I said, okay, x is 10, can you find the value of y?
Yeah.
It's just a fancy way of thinking of like y equals m times x. Like this.
So K is just M. K is slope, right?
I think I made that reference earlier. Yes.
Oh, wait, hang on. So, sorry. Why do we use K if it's already M in another?
Okay, so it's not m. We want to really, I really want you to get used to the constant of variation. Remember the
It's not
K? It's related to slope, but we're using it in a different context here. Okay. Also, remember when we did the y equals y naught e to the kt, and k was also a rate of change? That k is the same as this k. Like they're related to each other. There's a reason we use the letter K. It's not an accident. There's a reason we don't use M. Okay? Guys, please stop. I see you back there and it's annoying. Okay. Let's try the next one. Suppose Y varies jointly as X and Z. What does that mean? That means Y equals KXZ. So I'll show you again. We'll do the 2 different methods. On the homework, you pick whichever one you want.
Wait, but Ms. Vincent,
Mm-hmm.
what is like the x and the z? Isn't there only 2 variables, or what? How do you get?
What do you mean?
Like there's kx and z. What is?
Okay, so look, this is phrased, this sentence is phrased opposite from the last example. This one's saying, find y when x equals 10 and z equals 5, if y equals 12, when z, so this is the given information. This is what we want to find. Okay, so it's kind of phrased backwards from the previous one. So if I want you to find the value of k, I would use y is 12, leave k, x is 3, z is 8. So that's going to give us 24k. Oops. So k is 1/2. So the relationship between y and x times z is it's going to be 1/2. Right? So now I can figure out what y is equal to, right? Y is equal to 1/2 times 10 times 5, and what do we get for y? 25. Now, I can also use the proportion. So again, if I were to set it up using the proportion, how would this look? I would put 12 over 8 times 3. And then I would put y over 10 times 5. Right? So I'm putting y in the numerator and then x times e in the denominator, right? 12 over 8 times 3 equals y over 10 times 5.
I got y equals 25.
Yeah, I mean, you should get the same answer, right? So, and in fact, right, I have 12 over 24 equals y over 50. When we cross multiply, do we get the same answer? You get the same answer,
Why don't you?
right? Because this would be a half, 1/2 times 50, you get 25. Yeah, Lauren. Okay, so I have to say, because I teach calculus a lot, I actually prefer this method, the first one. Even though it looks like more steps, it will benefit you more to remember that format. So either way, it doesn't matter to me. But we'll do inversely proportional also in calculus. So we have, this will come up later.
Doing the first one would be better than doing the second one.
That's my go-to method because
Well, you'll be teaching us how. Yeah,
because often what they'll ask for is not even this answer. They want to know what is the equation relating the
We had two teach pre-cal.
Okay, so we'll talk about classes another time. So
I mean, she said she wouldn't be teaching,
very inversely, I like this format, y equals k divided by x. So this one looks a little different. Instead of directly is k times x. Inversely, think reciprocal, k time, yeah, it's really k times 1 over x, right? 1 over x is our inverse of x. So, but we just write it as k over x. Here it is as a proportion. So here x varies inversely as y. So I can write it x equals k over y or y equals k over x. It doesn't matter. You'll get the same result.
On this basic,
Mm-hmm.
like, would it be like k equals 96? Would it be like that high?
Well, yeah, what do you get? If x equals 24 when y equals 4,
You multiply both sides by 24, right?
yeah, so let's say I want to use this one. So here's what we know. This is what's given. And then this is what we want to find here. So if I want to find the value of k, right, 4 equals k over 24. So k is 96. So y equals 96 over x. So now I want to find out what x is when y is 12. Are we okay with this?
Then it'd be like 12 equals 96 over x.
So 12 equals 96 over x. 12x equals 96. X has to be equal to right? Good? I'm waiting. You can also use the proportional method. The difference with the proportional is that they're swapped, right? They're opposite of how I had the directly proportional. Yeah. It just means that's what we want to look for. If it says inversely, we're going to do the reciprocal of x. Uh-huh. Okay. Let's finish these last two, and then we have a good amount of time, and we can do some more examples from the homework, and I think it'll clear it up. Okay? All right, Zeev, sound good?
Yeah, I've got a question though.
Okay, length of a violin varies inversely. Let me finish these two, and then I can come back. As the frequency of its vibrations. Okay. Let's talk about variables. We need to establish some variables, and it says varies inversely. Now, it doesn't matter which variables we choose. We can make this L, we can make it Y, We can make this F for frequency. We can make this X. It doesn't matter. You want to just pick X and Y? So let's make the length. Let's say the length is, oops,
I want the length to be y.
Y.
Why?
Is it y
I got k equals 5,000.
Okay, so Y equals K over X. So the first thing I want to do is I want to just think about what does this sentence mean? Y equals K over X.
112.
Okay. All right, Jack, just, okay. Violin string 10 inches long vibrates at a frequency of 512 cycles per second. Okay. That gives us information to find K, which is our, right, that's the constant of variation. Okay, so which one was representing the length? That's Y. So that's going to be our 10 equals K over 512, which makes K equal to, good. Okay, so we have Y equals 5,120 over X. That's the relationship between the length, right, and the frequency. Now we want to find the frequency, which is X of what? An 8-inch, right? That's a value of Y. So I just want to, that's why when you're reading them, just kind of keep straight which one's X, which one's Y, because you don't know which one you're going to be solving for. So now we have this is 8.
640.
So it's basically X divided, or 5,120 over 8, which gives us 640. And since they gave us units, let's write 640 cycles. Oh, that was supposed to have a per. Does yours have per in there? I think I had fixed it after I, cycles per second. Okay. Last one. Oh, Lauren.
So when it says varies inversely, like this is the equation.
Yes.
Okay.
When it says varies directly, it's Y equals KX. When it says inversely, it's Y equals K over X.
Like that makes sense now. Okay.
Yeah. Okay, now this one we have two things going on. We have varies directly as G, and F varies inversely as H. So what do you think that's? So F varies directly as G, and yeah, K is always going to go on the top. So it varies directly as G, so it's going to be K times G, and inversely as H. So I'm going to put H in the denominator. It's whatever is inversely goes in the denominator.
So not inverse to other.
Direct, it was just K times that thing.
Wait, so if it's inversely to the denominator?
It's just K times that.
Okay. So F equals KG.
All right.
F equals KG and F.
So the first part, this is what we're trying to find. Shh. See? This is what we know. Right? So sometimes it's switched around, like what you know and what you're, look for the word find. Whenever it says find, leave that alone and work with the second part. Does that make sense? You know how sometimes it's like switched around? Yeah. So whenever you see the part of the sentence that says find, ignore that, do that second. All right, 6 equals K times 24 divided by 2. So what is our value of K? 1/2. Now I'm going to go back here. F equals, so it's going to be 1/2. Or we could make that G over 2H, because that's really the same thing, right? 1/2. Or you can make it 0.5, it doesn't matter. I mean, it'll all work out when we're answering the question. Oh, so now we're gonna, this was just my equation relating everything. Now I'm gonna plug in, F is 18, G is 24.
Oh, yeah, I get that.
Oh, sorry, F is 18 and H is,
So you have to
In
find
this case,
G, right?
H doesn't matter, right?
hold on.
We're finding.
F is
Yeah, so we
18.
don't need to use H at all, right?
Sorry, I didn't mean to put the 24 there.
I don't think so. I asked that me too.
2 times, we're finding out what G is when F is 18 and H is negative 3.
Yeah, but like, can't you just plug that into the direct variation equation?
Negative
I know,
9.
but how do you know?
What's negative 6 times 18? What's negative 6 times 18?
Negative
54.
Oh.
27.
Wait, what's it again?
I got negative 108.
Negative 108.
Yeah, it's negative 108. Lauren, we just did it differently.